Okay, so if that's the case, I would like to take this opportunity to welcome you into our programs of calculus and the engineering mathematics. So we'll have a class of almost, my lectures will be almost 1 hour and a half to 2 hours. So I will be giving you the overview of the entire module, and then we'll be picking the second topic, which is called the Laplace transform. So according to the DIT curriculum, you have to write this information. Is very important for you. The DIT curriculum or the DIT calculus or engineering mathematics cover the following topics. So the following are the topics that you are going to cover. Or the following are the topics that have to be covered. The first one, we call it the theory of limit. This is the first topic, and I have already taught you this topic by creating 10 lectures. So 10 lectures of limit are already at your hands. You have to make sure that you go through them. The second topic is called the Laplace transform. Laplace transform. This is the second topic that we are going to start today. The third topic, we call it inverse of Laplace transform. Inverse of Laplace transform. Inverse of Laplace transform. The first topic, we call it application. Applications of Laplace transform. The fifth topic is called the Fourier series. Fourier series. This is the fifth topic. The sixth topic is called the function of several variables. Function of several variables. Function of several variables. So these are the 6 topics of the modules. We call it in calculus, or in some other courses, for example, electronics and telecommunication engineering and computer studies, they call it in engineering mathematics. So according to the DIT examination setup, the first 2 topics, but before just explain to you about test 1, test 2, or the first test, and whatever, let me just give you a chance to cooperate. It means that to be involved in this class. Class, say theory of limit. Speak loudly, please. Say theory of limit. Sometimes that topic we call it limit, right? The second topic, say Laplace transform. I will ask you to pronounce these topics because you have to write them, so you have to remember them in your mind. So when you pronounce, then it is being written in your permanent memory. Okay? Because otherwise you'll be solving problems or solving questions while you don't know the name of the topic. And that is actual. It's very surprising for other people like you and I. The third one we call the inverse of Laplace transform. Say inverse of Laplace transform. And the fourth topic is called applications of Laplace transform. Then the next one is called Fourier series. Say Fourier series. And the last one we call the functions of several variables. Thank you very much for pronouncing them. So now listen. According to the DIT examination setup, the first chapter and the second chapter always used to formulate test 1. Stop writing, listen, and watch. The first topic and the second one, it means theory of limit and Laplace transform, I used it to provide the contents for the test 1, right? The first test, which usually in DIT, we used to test our students in the 7th week of the semester. So you just have only we have finished the 5 weeks, so you still have only 1 week of fighting day and night, right? Then This one, the inverse, the third topic and up to the fifth topic. Sometimes it can involve even up to the sixth topic. These are the contents for the test 2. Okay? So then, the first topic to the sixth topic, these are the contents for the final exam. The continuous assessment for calculus is 40 marks or 40%. The final exams will carry 60 marks. The minimum pass mark for the CA is 16 marks for calculus. The minimum pass mark for the FA is 24 marks. Okay? Are we together? The setup, in most cases, test 1 used to carry 15 marks. And test 2 used to carry 15 marks. So the remaining 10 marks is actual assignment. So assignment used to carry 10 marks. So this is the way that we assess the students. Are we together? Are we together? But another thing that which I want to introduce it to you, the goodness is the topic of limit is independent. It does not depend on any other topic, and also itself is not dependent by the other topics. So for instance, Laplace transform does not depend on the topic of limit. Okay? Again, inverse of Laplace transform depend the concepts of Laplace transform. Application of Laplace transforms depend the concepts of inverse of Laplace transform and Laplace transform. And then Fourier series does not depend applications of Laplace transform, does not depend inverse of Laplace transform, does not depend Laplace transform, does not depend theory of limit. So it means that this one, the Fourier series, it's a new concept. First of all, it's not, it's actually it's integration, but integrations and series. Are we together? In case of Laplace, inverse of Laplace and applications, this is all about integration. We'll be integrating in most cases. Okay? Applications of several, functions of several variables. Also, this topic is independent. It does not depend on any concept from the other previous 5 topics. Are we together? So this is the goodness of 40 of calculus. That sometimes maybe you may not have any idea about limit, but it does not limit you to go through Laplace. Right? So these are the 3 topics which depends to each other. So this one depends this one. This one depends the third topic and the second topic. Are we together? So that is. So that's why that I still ask you, make sure that you go through those 2 lectures of limit, because otherwise you remember me after test 1. And you remember what I have given you after test 1. Okay? Good. If you have any question, for those online students, you have to ask your questions in the comment. And for the physical student, you have to ask your questions physically. It means you have to raise up your hand or you knock, then I can answer your question. So this is chapter 2, which we call the Laplace transform. Say Laplace transform. Say Laplace transform. So Laplace transform, this is the phenomena which has been consisted by the 2 words, Laplace and the word transform. Are we together? So before we write its literal definition and mathematical definition, let me explain to you what the meaning of Laplace. Laplace, as a Laplace, it's a name of mathematicians. He has been a French mathematician. Okay? Are we together? So this is the name of the mathematicians who have discovered the concepts of the transform. And once he has discovered, then by to honor him, the concept, it has been called the Laplace transform. That's the meaning of Laplace. Okay? So his first name is Simon Laplace. So Simon's Laplace. Yes, Simon Pierre Laplace. That's the names of 40 of the mathematician. The concepts of transform. Say transform. Say transform. This is mathematical concept that we are learning, but in our daily life we used to experience it. Listen, stop writing. Do we know maize? Do we know maize? Tunafahamu mahindi? Zamani kabisa miaka ya nyuma, we as Tanzanians and even our grandparents, they used to cultivate maize, right? And then they can just harvest them and cook the way they are, right? Right? So they cook the way they are, but you know that they are not beautiful, eh? So there's a lot of unwanted materials, right? And then later on, they say, okay, let us transform this maize into another form. So they had actually that a system of grinding. Ya manake kwamba kuna kinu na mtoho. Kwa wakaanza kufanyaje? Kutwanga ile mahindi. Lengo ni kutoa pumba. Sawa eh? Kwa tukawa na mahindi ya nini? Manake asema kwamba tunakuwa na kande fulani hivi ambazo nasema ni kande zile, si ndio? Lakini kande bado pia ukitafuna mpaka uje ushibe meno nauma, si ndio? Bado chakula kijawa na kizuri. Baadaye wakaja na uvumbuzi wa kusema tunaweza tukayaloweka, tukaanika, tukatwanga, tukapata unga. Alafu tukasonga nini? Ugali. Lakini ukiangalia tulipofika kwenye ugali, hakuna tena kinachofuataga baada ya ugali. Yaani kwamba ugali, yani ule unga hauwezi kubadilishwa kaenda katika form nyingine. Tumeelewana eh? Sasa naposema kwamba manake pale tumefanya transformation ya mahindi kutoka kwenye phase au state ambayo ipo kwenda katika state nyingine. Sawa eh? Ya, kwa maana yake tumebadilisha mahindi kutoka kwenye hali ya mahindi ikawa unga. Sasa tapokuwa na unga, maana yake ladha ya unga na ubora wa unga ni tofauti na wa mahindi yale kabla hajasagwa. Tunaelewana eh? So when it comes for the engineering, listen careful now. Let me tell you the meanings of transfer in engineering. So in come for the engineering, it means that in case of processing different signals or different phenomena, then you know what used to happen? This is what used to happen. Some of the informations or engineering information cannot be processed and transmitted the way they are. So we have to transform them from their form into the another form. Right? So the form is just like maize. So the form that they are when we harvest them from the farm is not actually that suitable for the human life. Right? Similarly, in engineering, whether it's mechanical engineering, whether it's electrical engineering, or electronics engineering, or communication engineering, or maybe civil engineering, we have some phenomena, so some information that we cannot process them or transmit them the way they are. We have to transform them into a certain form or a certain shape. Right? So that's the meanings of Laplace transform. So this is the mathematical concept which we apply in engineering in order to design different systems, but especially for processing different signals. Because, for example, the concept of Laplace transform we use in electronics, we use in electrical engineering, we use in communication engineering, we use in computer engineering. So actually that we are transforming something into another form. Are we together? Then the inverse now, inverse of Laplace transform, we are restoring what we have transformed. Are we together? Are we together? So we are restoring what we have transformed. That means of inverse. But for transformation, we are transforming something which is complex into the simpler form. Are we together? Class, are we together? Okay. So he said that Laplace transform is the fundamental, this is fundamental topic of fundamental topic that has many applications. Many applications in science and the engineering. In science and engineering, because it is a tool for solving ordinary differential equation. Ordinary differential equation. So this is the tool of solving ordinary differential equation. So before I teach you the meanings of Laplace, let me present to you, or let me present to you subtopics of 40 of Laplace transform. Subtopics of Laplace transform. So the following are the subtopics of Laplace transform. The first one are definition. So I will teach you about definition of Laplace transform. Definition of Laplace transform. Definition of Laplace transform. The second one, we say that I will teach about Laplace. Laplace transform. Laplace transform of constant function. Constant function. The next is a topic that I'll teach you about Laplace transform of trigonometric function. No, of what? Exponential function. Exponential function. The next topic that I'll teach you about Laplace transform of hyperbolic function. Hyperbolic function. The next topic that I'll teach you about Laplace transform. Laplace transform of trigonometric function. Trigonometric function. Then the next subtopic will cover about Laplace transform. Laplace transforms of 40 of composite function. Composite function. The seventh subtopic that will cover Laplace transform of Laplace transform by shifting property. Shifting property. Shifting property. The next subtopic that you are going to cover is Laplace transforms of what? Of the form e power 80. Laplace transform of form e power 80 times FFT. The next subtopic is Laplace transform of form Laplace transform of t power n. T power n times FFT. The next subtopic teach you Laplace transform of the form FFT over t. FFT over t. Next one, number 11, is Laplace transform of 40 of unit step function. Unit step function. Unit step function and unit impulse function. Unit impulse function. It's better to tell you that where are we going. This is the one of the longest topic in calculus and engineering mathematics. The next one we call it the Laplace transform. Laplace transform of periodic function. Periodic function. Yeah, so in all of these 12 subtopics, we are going also to have what? We are going to have problem solving in each subtopic. So you are going to have 12 subtopics, which you have to cover them because each one is independent from the other one. So few of them which are dependent. Are you happy? Or you are thinking about your family? So we have these 12 subtopics. I don't want to explain in detail about this, actually that which subtopic is difficult. But I want to tell you that from this concept, from this one, subtopic number 8, from subtopic number 8 to subtopic number 12, this we call them special Laplace transform. They are a little bit challenging, and that's why that we teach them at the end of the topic, when the students has covered about this previous concept. These are the fundamental, but are very important. We'll be recalling them often. For example, from the constant functions and whatever. So for instance, for the other group of students that I've already taught, we have already covered the first 4 subtopics. Okay? So we've already covered the first 4 subtopics. So today, we had a responsibility to learn about trigonometry, and we cannot finish trigonometry because this is the one of the longest. We have to finish, I think that we'll finish it tomorrow in lecture 6. Lecture 5, when we finish about trigonometry. Trigonometry, at least we need 2 lectures, but because of time. But we can even, if you have enough time, we can even do 3 lectures or 4 lectures, because most questions are asked in trigonometric function. Okay? Emily, what are you doing, Emily? So let us start with the first subtopic. Okay? The first subtopic is what? Class, read it. 2.1 is called what? Definition of what? Definition of Laplace transform. So ask yourself first, what the meaning of Laplace transform? Before I mention the subtopic, before I mention the subtopics, I explain to you the meanings of transform. So can you now define? This is question 1. What is Laplace transform? What is Laplace transform? What is Laplace transform? What is Laplace transform? Okay? Yeah, what is Laplace transform? What is Laplace transform? That's the question. Ask yourself. What do you understand about Laplace transform? Huh? Okay. So we are going to define these terminologies Laplace transforms in 2 ways. Dx. Literary and mathematical. So instead of A, I gave you B. Are we together? So the meaning of Laplace transform is the integral. Is the integral transform that is useful in solving, is the integral transform that conveys the functions of real variable to the functions of complex variable. So Laplace transform. Say again Laplace transform. Emily, say it, Laplace transform. So Laplace transform, we say that is the integral that transforms the real variable function. The real variable function into the complex variable function. Complex variability function. So from this definition, we find two vocabularies. Real variable function, first of all, we find its integral. The second one's transformation. So in this definition, we find 3 or 4 terminology. The first one, Chilonga, listen before you write. The first terminology, Laplace transform is the integral. So from the definition, we are well prepared that we are going to deal with the integration. Right? Laplace transform is what? Is the integral. Integral, that's what? That transform. So that change something, right? Okay? That transform what? A real variable function into a complex variable function. So before you write, let me give you simple examples. So here we have actually we have a real variable function, which we are familiar with. And then here we have a complex, say complex variable function. Say complex variable function. So a real variable function is just like when we used to have f of x, let's say is equal to x squared plus 4x plus 2. This is the real variable function. Or, Emily, don't write. Maybe f of t is equal to 2t squared, maybe minus 2t plus what? Let's say 3. This is the real variable function. A complex variable function is, for instance, that I have, let's say, 3s over 2s squared plus 4. This is the s now. It's a complex variable function. So the real variable functions, we used to express them in terms of x or t. We are familiar with these functions. So it means that Laplace now has a responsibility to transform this real variable function that we know into the complex variable function. Okay? So this is the one of the complex variable function. The other one, it can be, let's say, 3s squared plus 4s, then over to 3s squared plus 6 s plus 2. So these are the complex function. These are the real variability functions. These are complex variable function, real variable function. So now here we have a tool we call Laplace transform. So Laplace transform will be transforming these functions that we know, but in engineering it's difficult to process these functions the way they are. So we have to transform them into the complex variable function. Right? We process, we do different manipulations, and then if we wanted to restore the previous function, that's why that we have to come for the inverse. So the inverse of Laplace transform is actually transforming the complex variable function into the real variable function. Are we together? Are we together? Yeah, so that's the meaning. So this is the meaning of 40 Laplace transform. Do you have any question? You have any question? Amos? Chilongani? You have any questions up that point? No, things are still simple. Okay, you'll have questions later on. Emily, do you have any question? Eh? No. Eh? Sure. Okay, so then mathematically, let us now see, we are still answering the question, what is Laplace transform? Mathematically, we define separating. We define Laplace transforms in this way, mathematically. So mathematically, we define Laplace transforms of f of t. This is equal to what? Integral from 0 to infinity, e power negative st f of t dt. So this is the formula of Laplace transform. You have to remember it from today onwards. Or, in other words, if the function is expressed in terms of x, we say Laplace transform, this is the curly bracket, Laplace transforms of f of x, like this, is equal to integral from 0 to infinity, e power negative sx, then f of x dx. So this is another way we can express Laplace transforms of the function mathematically. Are we together? Are we together? So Laplace transform is the integral. Remember from the definition, Laplace transform is the integral. So where is that integral? This one. This is the integral sign. Right? That transforming what? A real variable function. Where is that real variable function? This one. Right? Into what? Into a complex variable function. Where is that complex variable function? This one, the function of s. So the result that we'll get after finding the integral from 0 to infinity of e power negative st times f of t dt will be a transformed what? Function. Are we together? So listen again. Also, we can write these formulas in this way. Laplace transform of what? Of f of t is equal to f of s. The capital F are the function of s. Remember that this is a real variable function. This is the complex variable function. Are we together? And then this one is equal to integral from 0 to infinity. Then e power negative ss power negative st f of t dt. So this is another way that we can express the formula of Laplace in mathematics. Are we together? Yes. So when we ask the question, what is Laplace transform? You have to give this literal definition and mathematical definition. Is it clear? Is it clear? Yeah. So if you have any question, you may ask me. So you have to remember this formula for the first chapter, for the second chapter, for the third chapter. For the second chapter, third, and the fourth. We'll be recalling this formula often. So everything is clear. So that is all about introductions of 40, definitions of 40 of Laplace transform. So we go 2.2. In 2.2, now let us go to learn Laplace transform. Laplace transform of a constant. Laplace transforms of a constant function. Laplace transforms of a constant function. So while you are copying or you are taking a note, now let us go and discuss about Laplace transform of a constant function. Of a constant function. A constant function is a function which does not have a variable. That means of a constant function. It's a function which does not have a variable. For example, f of t is equal to 2. So 2 is just a constant number. F of t is equal to negative 3. Negative 3 is just a constant number. It's quite different if I say that f of t is equal to 2x or 2t. Okay? So we say that, let's start this one in form of the questions. Example, this is the example 1. Okay? So you say that, given f of t is equal to a, find Laplace transform of f of t. Engineers, this is a curly bracket, yeah? Curly bracket. So given f of t is equal to t is equal to a. Find Laplace transforms of f of t. Find Laplace transforms of 40 f of t. Or, in other words, you can find the question set being asked like this one. Show that Laplace transforms of a is equal to a over s. Have you finished to copy this? Are you done on this part? So now we are going to learn about the second subtopic, which is Laplace transform of a constant number. Laplace transforms of a constant function. Laplace transforms of a constant function. Given that f of t is equal to a, find Laplace transforms of f of t, or show that Laplace of a is equal to a over s. So, engineers, let us solve this simple question. Remember that, don't expect you to be asked a simple question like this one in the exam. These are the key points that we need later on, right? To deal with special cases of Laplace transform. But these are the simple questions. Don't expect them in the exam. Even if that for 0.5 marks, you will have 0.2, 0.5 marks of free. Because it's simple. So solution. Usually I used to teach my students, and even if that you go through the previous lectures of the topic of theory of limit, I used to teach by following steps and writing the steps. I used to teach different concepts of mathematics and engineering and science by following steps. And that actually used to give my students a good chance for simple revision, because you know what are we going to do. And even if you revise after months, you still remember in case that you forgot, but you have written so you can go through. So you know that the next step, what are we doing? We are doing this one, right? So that's the style, and it's a very special technique that I used to teach students. Okay? So I'll be writing the first step. So even yourself, remember that, or adapt this system that I'm teaching you because it's helpful. The first step, we say that recall the general formula of what? Of Laplace transform. So of Laplace, because Laplace is, the symbol is L, of Laplace transform of FFT, let's say like this way. So the general formula states that Laplace transform of FFT, this is equal to integral from 0 to infinity. Then e power negative st FFT dt. So this one, we can call it, this is question 1. Okay? Stop writing, listen, and watch. So this is the general formula of Laplace from that definition, right? Eh? But we've been given from this function that FFT is equal to A. So this is equation 2. So then we go for the second step. The second step, we say that substitute equation 2 into equation 1. So to substitute equation 2 into equation 1, we say that Laplace transform of what? Of A is equal to integral from 0 to infinity. Then we have e power negative st. Then we have what? FFT. So that FFT, we put A, then dt. Are you together? So this one, we can have this one. We can have integral from 0 to infinity, A, e power negative st, then dt. Okay? But remember that A is constant. Remember that. We say that A is constant. Constant number. A, it can be 2, it can be 3, it can be 4, it can be 20, it can be 30, it can be 100. It's any constant number. Okay? So if it's any constant number, according to the rules of integral, we can take A out of the integration side. I'm waiting you to stop writing. So for that case, we can take A out of the integral sign. So integrate from 0 to infinity, e power negative st dt. Are we together? Then, if this is the case, we have A. So now we need to integrate from 0 to infinity, e power negative st, then have what? Dt. Okay? If that's the case, what do we say? We say this one. So you go for the third step. The third step, I'll just remind you that we taught you in ordinary diploma and even advanced secondary education that whenever we integrate, so you have to note these two. So the first step we say that we call. Number 1, whenever that you're integrating e power x, or let's say e power t dt, the answer is e power t. Are we together? Are we together? Are we together? Are we together? We are not together. This is what usual. Previous we didn't teach you as the function of t. We taught you as the functions of x. Whenever we integrate e power x dx, the answer is e power x. Okay? Then we remind you, this is number 1. We remind you. Also, when we integrate e power negative x dx, the answer is negative e power negative x. Are you together? These are the constant integrals. They don't change. They will never change. They just have this style. So it means whenever that you integrate e power something, the answer is e power something. So when you're integrating this one, e power negative something, the answer is negative e power negative something. So keep that in your mind, because we are going to use them often. Okay? So listen, the third point to note, if you're integrating e power ax, where a is constant, the answer is e power ax over a. So I just remind you what we taught you in OD, because you have forgotten it. Okay? This also is a constant, right? When we ask you to integrate e power negative ax dx, the answer is negative, as we say there, e power negative ax over a. What does it mean? For instance, if you be asked that to integrate e power 2x dx, the answer is e power 2x over 2. Okay? Okay? Okay or it's not okay? Jamani, sasa kufundisha wanafunzi bubu. If you're integrating e power negative, let's say 6x dx, the answer is negative e power negative 6x over 6. Are we together? Are we together? Why did I revise these materials, or why did I ask you, why did I teach you about this concept? It's because now we need to integrate this function, which is this form. Okay? That's why that I have reminded you about the first concept, the second concept, the third concept, the fourth concept. My intention is in order to help you to understand how we integrate this. Okay? So I know that possibly because you did your ordinary diploma so many years ago, I have to remind you. So listen. If that's the case, you say that now we had Laplace transforms of a. We had a integral from 0 to infinity, e power negative st dt. Do you agree? Huh? So if you integrate this one, this is like what? Like which concept among the 4 concepts? Concept number 1, number 2, number 3, number 4. This one. Number 4. Because remember that s is always constant. The variable here is t. S haibadiliki, ni kama 2 hapa ilipokaa, ni kama 6 ilipokaa. S hii haibadilikagi. Sawa? T ndio inabadilika. T ndio inakuwa kama x hapa isipokaa hapa juu. Okay? Are we together? So if we integrate this one, what are we going to get? A, we open square bracket. We are going to have what? Speak it loudly. Negative, e power negative st over s. Very good. From what? 0 to what? Infinity. Because these are the limits. Have you finished to copy here? Amos, is it okay? Hi. Don't write. Just stop. Let us finish these derivations, and then I will give you some few minutes to copy. But I know that will be hard because you'll be copying the materials which you have understood. Hi, let us continue. So we are looking Laplace transforms of a. Here we have a. So listen, s is constant. T is the only one that's changing. Okay? So we allowed you to take s out of the bracket. Are we together? Are we together, class? And we can even take this negative out. So now we have negative a over s. In this bracket, we remain is e power negative s t from 0 to infinity. Are we together? Are we together? The next step, we say that this is negative a over s. Then we open bracket. We have to substitute the upper limit and lower limit into the t. So you have to replace the t with the upper limit, which is infinite. And you have to replace t with the lower limit, which is 0. Are we together? And the concept that you have to use is this one. We told you if you're integrating f of x dash dx from a to b, we told you in OD that the answer will be f of x when x is equal to b, minus f of x when x is equal to a, like this. Do you remember that? So you are going to use this concept. We're going to use, this is concept number 5. We're going to use this concept to integrate this one, to substitute the limits. Okay? Okay. So we are going to have e power negative s times infinity minus e power what? Negative s times what? 0. Are we together? Mathematics is beautiful. Laplace transform of a is equal to negative a over s. So then s, suppose s is a certain number. For example, 2 or 3 or 4, it's a small number. So a small number times infinity, the answer is what? Not 0. Infinity, it's a large number. You have trillion, for example. 1 trillion. Then we take 1 trillion times 2. The answer is still trillion, So infinity times a small number, the answer is still what? Infinity. Small number over infinity, it's one that gives us 0. For example, you have maybe, you have 1,000 Tanzania shillings. And then you want to divide to 60 millions, 60 millions of Tanzanians. How much will each Tanzanians get? 0. Jamaa una 1,000, una shilingi 1,000, unawagaiwa Tanzania milioni 60. Kila mtu anapata shilingi ngapi? 0, si ndio? Kwa maana yake kumbe namba ndogo gawanya kwa namba kubwa ndio jibu inakuwa 0. Ila namba kubwa mara namba ndogo jibu ni namba kubwa. Sawa jamani So here negative s times what? Infinity. The answer is negative what? Negative what? Minus negative s times 0. Any number times 0? 0. So e, do we have negative 0? We can have negative 0, but it does not exist. So e power 0. Are we together, engineers? Then, if that the case, we continue. Laplace transform of a, negative a over s. We have e. So e power negative infinity. This one, to know the answer of e power negative infinity is equal to what? Let us take our scientific calculator and find e power negative 9 exponent 99. The answer is equal to what? Because 9 exponent 99 is a very big number. Right? It means you have 9 and 99 zeros after 9. Is that a trillion or what? It does not have even the name, So now, so take your scientific calculator. Do you have your scientific calculator? If you don't have, you have to check your neighbors. Wagora, do you have your scientific calculator? So take it and then press alpha. So once you take your scientific calculator, press the button, turn it on, and then press the button which is called the alpha. Alpha, it's red in color. Alpha. Then go and find a button which is written LN, which means loan. On top of it, you'll see E. Have you seen? Chilongani? Do you have a calculator? No, so you have to check from your neighbor. Very important point. Just please cooperate. Your neighbor knows about that because he attended the previous lectures. So I said press the button written alpha, which is red in color. Ready? Then find the button which has been written LN, means loan. On top of it, you'll see E. Ready? Once you see the E, I think you saw the E. Or you see the E on the top of your display? You are seeing E on the top of your display. Press the button of equal sign. What the value of E? 2.718, etc., etc. That's the meaning of E that we are using in mathematics. Are we together? So E is a constant in number, which is 2.7182, whatever. That's number one. Number two, now we want you to find E power negative 9 exponent 99. So press alpha again. Ready? Press the buttons that returns long to get E. Ready? Then go and press the button which has been written as this way, power. The buttons of power. Ready? Then write negative 9 and press the buttons written E in order to have, and then write 99. The buttons written exponent. After negative 9, press the buttons written exponent. Ready? Almost. Are you done? You have it? So I think in your calculator you have E power. So it has been written. I think it will be written. E power negative 9. Then this one symbol like this way. Is it? Do you have something like that? No. Where are you lost? So look here. I said you have to press alpha, then E, right? Then power, then negative 9, then exponent. What? 99. Hey, Emil. Hey. So once you have this one, press the equal sign. The answer is what? 0. It means from today onwards, you have to know as engineer, E power negative infinity, the answer is 0. E power negative infinity, the answer is what? 0. Thank you very much. The answer is 0, right? Chilongan, look here. So E power negative infinity, you told yourself that the answer is what? 0. So we put 0 here instead of E power negative infinity. Minus E power 1. Any number power? No, E power 0. E power 0. 1. So now we have 0 minus 1. Negative 1. Negative 1 times negative A over S. So Laplace transform of A is equal to positive A over S. So we say that hence shown or proved. So remember this. Let me give you 1 minute to copy. Yes, you like to copy, eh? Did you understand? Okay, so that is, let us see some examples of Laplace transform of a constant function. Laplace transforms of a constant function. So the Laplace transform of constant function, we had example 1. This will be example 2. We say that, let us find Laplace transforms of the following function. Roman A, f of t is equal to 5. Roman B, f of t is equal to, let's say 20. Roman C, f of t is equal to a half. Roman D, f of t is equal to 3 over 5. So these simple 4 examples can give you the big picture of what? Of Laplace transforms for the constant function. Solution. This is a very simple question. Solution. So the solution, we say that the first step, stop writing, we have to recall the formula, the general formula. So this we call the general formula. You have to recall the general formula of Laplace transforms of what? Of a constant number, which you call the Laplace transform of what? Of A, which is equal to A over S. Are you together? A over S. So in this one, we say that Roman A, we are looking Laplace transform of what? Of FFT, which is equal to what? Laplace transform of 40 of 5. The value of A is 5. So it will be 5 over S. So simply say that Laplace of 5 is equal to 5 over S. Okay? So you'll try B. Okay? Let me do D. Roman D, Laplace transform of what? 3 over 5. This is equal to what? Remember that the value of A is 3 over 5. Okay? So this is equal to 3 over 5 divided by S. Okay? So this one is equal to 3 over 5 divided by S over 1. Okay? So because we are dividing fraction, so 3 over 5, we change the operation from division to multiplication. Then we reverse what? We reverse the numerator into denominator and denominator into numerator. So the answer is what? 3. The answer will be 3 over 5s. Okay? So simply, it means that the Laplace transform of 3 over 5 is equal to what? 3 over 5s. At the response. Simple. How to wait? Where? Chilongani. You have to take photo. You have to take photo. Next time you have to take photo, okay? Yes, and you have to hurry up, okay? So the second constant number is Laplace transform of FFT is equal to negative A. Is equal to negative A. So this is simple. Listen. Laplace transforms of FFT, whereby our function is negative A. This one is equal to negative A over S. Okay? So for that case, if you are looking Laplace transforms of negative 60, the answer is negative 60 over S. Simple like that. If you are looking Laplace transforms of negative 3 over 7, the answer is negative 3 over 7 over S. Okay? Which simply is equal to what? Negative 3 over 7 what? S. So that's the concept of constant number. So it can be either, even if that you'll find the Laplace transforms of a decimal number, negative 0.73. So the answer still is what? Negative 0.73 over S. Okay? Yeah, so that's how the concept is simple. You have any question? When we give it, that is enough. It's a matter of substituting and just translating the meaning of A. Remember that sometimes also you have to note, in some of the books you can find this one, instead of A, you can find Laplace of B. So even if that B, if B is constant, it's always constant in Laplace, the answer is B over S. In some of the books you can find that the constant is not A, it's not B, but is C. The answer is still C over S. So be familiar with that one. Right? Then, if that's the case and everything is clear, let us go to the third subtopic, which you call the Laplace transform. Laplace transform. Laplace transform of natural, Laplace transforms of natural exponential function. However, that we call just Laplace transforms of exponential function. Laplace transforms of natural exponential function. Natural exponential function. So, sometimes you may just can find that the teacher gives you the formulas and ask you that to claim them. But sometimes there are some questions I remember that they have been asked in final exam. You have to prove those formulas. Okay? Students, listen. Sometimes some of the teachers, they can just give you the summary of the formulas of 40 of Laplace transform. And then they ask you to claim them or to keep them in your mind. But I know that there are some, I remember that 2018 and 2019 and even 2021. In test 1 and final exam, they ask you students to prove those formulas. Right? So that's why that I'm teaching you how to prove, and I will teach you how to use them. Okay? So you'll be in the good positions to answer any question. So here we have example 3. So example 3, we say that given FFT is equal to e power 80, find Laplace transform of FFT. Or the same questions you can be asked that show that Laplace transform of e, Laplace transforms of e power 80 is equal to 1 over s minus a. Show that Laplace transform of e power 80 is equal to 1 over s minus a. Or it can be given the functions as e power 80, find Laplace transforms of FFT. So listen, maybe today we are finding the Laplace transform of this function when the constant is a. Maybe in exams the constants might not be a, it can be b, it can be c. You should not be confused. It's still the same question. So for you, Comba, you can even just try to derive this formula quickly on rough, just as a matter of practice. Do you still remember the materials or you have forgotten? Okay? So you have to derive it quickly. Yes, the matter of letters. And you have to know those letters because they can really confuse you. You might think that this is another question. It's a new question. Okay. So these are the questions. We are going to follow a number of steps to solve it. So stop writing. I have this space. I have this space. So stop writing, listen, and watch. Solution. So the first step is this one. We say that recall the general formula of 40 of Emily. General formula of Emily. But we write general formula of Laplace transform. We are waiting Emily transform. So the general formula of Laplace is what? FFS is equal to Laplace of FFT. Tell me, students, remind me. General formula of Laplace transform. A. Speak loudly. Integral. Chilongani. You are Chilongani. Yes. Integral from? dt. Very good. So this one will be question 1. Okay? Which functions are we given? The function which are given, FFT is equal to what? E power. This is equation what? 2. Right? So if this is equation 2 and this is equation 1, so you can find that we can replace this FFT by what you have been given. Okay? So you go for the second stage. Chilongani, you are still in writing. Substitute what? Substitute equation 2 into what? Into equation what? 1. Okay? So we have Laplace transforms of what? E power 80. This is equal to integral from 0 to infinity. E power negative st multiplied by what? FFT, which is e power 80. Then we have what? Et. So simply, it means that this one, let me write it clearly. Integral from 0 to infinity. E power negative st multiplied by e power 80 dt. Okay? So with this formula, or what we have here again, we have to remember what we taught you in basic mathematics form 2. The first topic of basic mathematics form 2, we call it exponents and radicals. Right? In exponent, we taught you that if we multiply two exponential functions of the same base, we have to add what? The exponent. Do you remember that? Those days when you've been expert in what? In mathematics. So simply say that the third step, let us recall that if you have a, or let's say we have, yes, you have a power x times a power y. This is equal to a power x plus y. This is, don't write this one in the exam. This is just for you. Right? Don't write this formula. Just this one, I just remind you about the previous concept that you've forgotten. Are we together? Yeah, so this is for you. So then Laplace transforms of e power 80, if you apply that exponential law, is equal to integral from 0 to 80 to infinity. E power negative st plus 80, then what? Et. Are we together? Then this one is integral from 0 to 80 to infinity. Then you have what? E power what? Negative, open bracket. Okay? So listen. S always, whenever you find that you have negative S always has to be positive. That's why we took this negative out. But let me not take S out first. Here we have t, we can take it out of bracket. So we'll have what remains negative s plus a times t. But here is your t, dt. Okay? So s should always be positive. So if s should always be positive, we have to take this negative out. So then we are going to have what? Integral from 0 to 80 to infinity. E power negative. So if we take negative out, s become positive, but a become negative. So we have s minus a, s minus what? Minus a, t, then what? Dt. Are we together? Are we together? So if this is the case, we say that Laplace transform of e power 80 now is equal to integral from 0 to infinity. Then you have e power negative s minus a t dt. So you have to remember the principle that I taught you. But because it's possible you have forgotten, let me remind you. Let me remind you the formula of integrations, or the integral formula that I have introduced it to you. Look. I told you that whenever we integrate e power negative ax dx, the answer is what? Negative e power negative ax over a. Chilongani, I remind you this one, which I taught you a few minutes ago. So you are going to use this concept to integrate this function. If you agree that Laplace, so therefore, Laplace transforms of e power at is equal to what? Is equal to integral from 0 to what? To infinity. We had what? E power negative s minus a t dt. So this one is equal to what? Negative first. Okay? Then what? E power what? Negative. What? S minus what? A t divided. This is our constant today, s minus a. Then we put our square bracket so we can introduce our limits from 0 to infinity. So Chilongani there is smiling that now things are already things. Possibly, I guess that you didn't understand for the way that you look like. You didn't understand. Let me repeat. So delete the information that you have learned. So your mind now say, let me listen carefully. We are finding Laplace transforms of e power a t. The formula is integral from 0 to infinity, e power negative s minus a t dt. Right? So if you integrate this one, we get what? E power negative s minus a t over what? So this is our constant. We have negative first. Right? This is just like a. Okay? So our a today is s minus a. Our a is s minus what? So as just what we have done here. We integrate e power negative ax dx. It's e power negative ax over a. So now our a is s minus a. So for that case, you have negative e power negative s minus at over what? S minus a. Are we together? Remember, s is constant, a is constant, e is constant. The variable is only t. Okay? So then we put what? Our limits, which is 0 and what? 0 to infinity. Are we together? If that's the case, I'm allowed to take this negative out. I will have negative 1. These two are constant. I'm allowed to take it out of the bracket. I will have negative 1 over s minus a. Okay? 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 Okay. So here we have what? E power what? Negative s minus a t. Then from what? From 0 to infinity. Emily, are you there? Have you copied this? Okay. So if that's the case now, the next step, we have to substitute limits. Mathematics is a beautiful subject, and mathematics is not difficult. So you have to substitute. We are going to substitute our limits. This is the upper limit. This is the lower. So let us substitute together. Laplace transforms of e power at. This is equal to what? Is equal to negative 1 over s minus a. So you are going to have what? E power negative what? S minus a multiplied by infinity. Okay? Minus e power negative s minus a multiplied by 0. Okay? So Laplace transforms of e power at is equal to what? Negative 1 over s minus a. So negative s minus a times infinity. S minus a times infinity. Infinity. So e power negative 40. Then here we have what? S minus a times 0. S minus a times 0. Any number times 0. Any number times 0. Chilongani. No. I asked you that any number times 0. 0. So here we are going to have e power 0. Remember, negative 0 is equal to positive 0. Okay? Eh? So you go for the first step. The first step, we have already discussed, and I showed you that so you say but e power negative infinity is equal to, right? E power negative infinity is equal to 0. And also we discussed that e power 0 is 1. Okay? So if that the case, Laplace transforms of e power 80 is equal to what? E power negative infinity 0. No. Negative 1 s minus a, right? E power negative infinity minus e power 0, 1. So negative times negative, 1 over what? S minus a. So it means that therefore, we have shown that Laplace transform of e power 80 is equal to 1 over s minus a. So hence shown, if you may ask you to show, but this is the formula that we need to use. Is it clear? Yes. Okay, so take a note. Okay, so the next concept, once you have this standard formula, that Laplace transform of e power 80 is equal to 1 over s minus what? A. See here? Then, if you have that formula, then now we have to do some examples. So here it's example 2. So here it's example 4. So example 4, find Laplace transform of FFT of the following function. So the first one is e power 2t. The second one is e power 3x. The third one is e power 1 over 3x. The fourth one is e power 0.6 t. So this is these are the simple question solution. Stop writing. Solution. So solution, we say that for Roman 1 and Roman 2, the first step, you have to recall the general formula of what? Of Laplace transforms of e power 80. So Laplace transforms of e power 80 is equal to what? 1 over s minus a. Right? Stop writing. So for that case means that for Roman 1, Laplace transforms of e power 2t, this is equal to what? 1 over s minus 2. This is the response. Okay? Then, for Roman 3, we have to recall the formula of Laplace transforms of what? E power ax. The answer is still 1 over s minus a. Because the variable here is x. Okay? So for Roman, I think that for Roman 3. So for Roman 3, we say that Laplace transforms of e power what? 1 over 3x is equal to what? 1 over s. Yes. This is the response. Yes, you can simplify. So to simplify, we have 1 over s over 1 minus what? 1 over 3. So then we have what in denominator? The LCM between 3 and 1? 3. Right? So 3 over 1, 1. 1 times s, it is 3s. Then 3 over 3, 1. 1 times 1, 1. And here in numerator, we have 1. So simply is equal to what? 3 becomes what? Numerator. So it will be 3 over 3s minus what? Minus 1. Yeah. But I told you that these are still simple Laplace transform function. A power 1 over 3x is equal to what? Is equal to 1 over s minus, we said that 3s minus 1. So for the decimal, or for Roman 4 and Roman 2, you can solve it. So now it's a time for the homework. This is homework 1. Remember that this is lecture 1. We call it lecture 00, General Introductions of Fourth Laplace Transform. The homework 1 is this one. Given f of x is equal to a power negative bx, find Laplace transform of what? Of f of x. Given f of x is equal to a power negative bx, find Laplace transforms of f of x. So that's the homework. And once I give you the homework, this is the end of lecture 0 or lecture 1. So you can call it lecture 0 or lecture 1. So this is the end of lecture 1. This is what we have covered, or we have to cover in the first lecture of Laplace transform. So we have, so if you remember that what we've covered, we covered the contents of Laplace transform, the contents of calculus or engineering mathematics, and also we've covered about what. So stop writing. Let us review what we have covered. So what we have covered, first of all, I introduced to you the topics we have in calculus, right? The first one is what? Theory of limit. The second one is what? Laplace transform. The third one is what? Inverse of Laplace transform. The fourth one is what? Applications of Laplace transform. The fifth one is what? Fourier series. The sixth one is what? Function of several variables. You didn't keep them in your mind? You still have a list of first 11 of Simba, or first 11 of Yanga. Then the next concept, I explained to you about what the meanings of transform. But mainly we define the meanings of the word Laplace transform. So you say Laplace transform is what? Is an integral that transforms a real variable function into a complex variable function. Mathematically, we define Laplace as what? Laplace of f of t is equal to integral from what? 0 to infinity, e power negative st, f of t dt. Or Laplace transforms of f of x is equal to integral from 0 to infinity, e power negative sx, f of x dt. Right? Then the next concept, I listed the subtopics that we are going to cover. How many are they? 12 subtopics of what? Of Laplace transform. Okay? Then another concept that I've told you, Laplace transforms of constant function. Laplace of a constant function a is a over s. Then the next concept is what? We covered Laplace transforms of natural exponential function. Means Laplace of e power at, but I left the homework for you to find Laplace of e power negative b x. But remember that lowercase a, lowercase b, lowercase c in Laplace are constant, right? And also in the general formula of Laplace transform, we say that S is constant. The variable is T or X. Are we together? So join me in the next lecture, which will be lecture 2, when we are going to learn about Laplace transform of hyperbolic function. Okay, lecture 3 will be learning about Laplace transforms of what trigonometrical function. Okay, so do you have any question? No, so keep on noting, because you can note all the other information and you forget the homework. So when I will ask you the homework tomorrow, you say that, given f of x is equal to e power negative bx. So instead of a, I gave you b.